This is the ride down the escalator as we enter the work floor. This is the glorious view you get when you start your day's work. We're in the Brooklyn Processing and Distribution Center. We're looking at DBCSs. These are delivery barcode sorters. Each machine is labeled with a number. We have approximately 30 machines standing now in front of DBCS 18, and you can see the size of this thing is rather large. It's a very long machine. I'm going to back up a little bit here so you can get a look at the console. Here's the console where the operator sits and processes the mail. We're going to open up all the panels so you can see what's inside this thing. This is the feed arm where you load the mail in. We'll run a test deck later. We'll see a test deck running live. This is the feeder. Machine has two computers. Depending on the needs of the processing plant, these machines can have many distribution pockets, as we're looking at here. For instance, this is pocket number 76, and as you can see, there's 4 tiers. Machine is made up of modules. Each module has 16 pockets. This particular machine goes up to 206 pockets. I'm at the back of the machine now looking forward. And these machines are serviced on a daily basis. This is number 18. We have to vacuum them and check the entire machine from end to end, give it a look, make sure all the belts are good. And like I said, we're going to open up some panels and take a look at the inside. This is one of the vacuum cleaners we use to vacuum out the dust of these machines, which is an incredible amount of dust considering that this is all letter mail. Each machine probably can process anywhere from 100 to 300,000 pieces a day. So we have these huge vacuum cleaners that hook up to a manifold, which I'm looking at now, and each vacuum can service 4 machines, but you can only pull vacuum on 2 machines at a time. Very large, very powerful vacuum cleaners. And we have piping on all the machines, runs the length of the machine, and there are ports at specific places to allow you to connect your hose, so no matter where you are in the machine, you can have access to a vacuum port. That blinking light is just telling you that the computer is up. That's the main computer in the machine. And as they sit idle and ready to operate, you'll see the amber light. If you open up a panel, like right now I'm going to open up a door, it'll change to a red light to let you know the machine is not ready to operate. And you should get a light on the panel. Apparently we got a burnt bulb here. This light should be on. So we're going to be changing that bulb as part of the service on this machine today. Okay, we changed that bulb. You can see now it's lit up. That indicates that door is open. If I pick up this lid, you can see the inside of the machine. This is the inside of the feeder. You can see all the dust in this thing. Pieces of paper, whatever. Now you'll get another light on telling you the front of the machine is open. And if you open up a back panel on one of the stackers, you will see the third light come on to let you know that you have a door open. Machine is loaded with emergency stops, which is one right up here. So if there's something happens, somebody gets their arm stuck in the machine, you just hit this, the machine immediately grinds to a halt. Part of the daily route on these things, you have to clear all this junk from behind the machines that the operators put up against the machine that they're not supposed to. But we do this on a daily basis, and then we start taking the machine apart removing this panel, and you start to get into where all the dust is and where all the vacuuming has to be done. We're going to open up more panels and get a better look at the inside as soon as I move away all this junk in the back, and we'll continue. Okay, here we have the machine locked out to be serviced. We're going to vacuum it. You can see all the dust and dirt that's in this thing. This is from one night's processing. That's what this panel has been removed. The panel standing up right here. Just to give you an idea. It's hard to see the fine dust, but this whole thing is coated with fine dust. Some stray mail in there. These panels here are all going to be removed. You can see that's all dust you see on there. All fine dust has to be vacuumed up. We'll walk over to the reader. See more pieces of mail. And some shredded mail, which occasionally does happen. Okay, we started vacuuming this thing. See how nice and clean it is now. I didn't touch the feeder yet, but I opened it up. And take a look inside the feeder, and you can probably see all these paper bits and dust. The pick-off belts are kind of worn. And we're going to clean all this up. There's our brand new set of pick-off belts we're going to install and get this baby like brand new again. This is the result of probably 175 to 200,000 pieces of mail to accumulate this kind of dust and dirt, which is about average for one of these machines in one evening. Each one they'll run about 175,000 pieces of mail. There's one small but very important detail you should always remember when mailing a letter. The back flap, if at all possible, you should always tape down the corners. As you can see, this section of the machine, which is right near the front, we're at the just past the feeder. This is called the transport. All these little bits of paper you see here are all the back flaps of envelopes. I'll pull this belt back. You can see them all in there. Very common for this machine to tear them off for whatever reason. I don't know exactly what causes it, but it happens all the time. Now randomly I'm going to go pick another machine. I'm going to show you the same spot in another machine. Okay, when I saw this, I just had to film this. This is exactly what I was talking about, although this is a very, very extreme case. I mean, just take a look at all these back flaps in this machine. This is the most incredible thing. This is absolutely incredible. This is a FiOS advertisement. I mean, there is like 2 pounds of this stuff in here. But again, that's because the back flap was probably raised up a little bit. This is commercial advertising. It's made by machine, and it's just been destroyed by machine. But this is an incredible case, and not terribly unusual, just that the amount that's here is rather unusual. Okay, I just moved everything out of the way. I'm standing just about in the middle of the back of this machine. You can see all the doors are still closed. I haven't opened anything yet. And all these red things are all emergency stops. And you can see these signs we have on the doors that no one really pays attention to. So this is the back of the machine, and we're going to open it up and take a look at what's inside. Okay. The machine has to be powered down before we open it up for safety reasons, so the machine is now powered off. I have just the first few stackers open. One stacker, as I said, consists of 16 bins. You have 4, 4, 4, and back under here, 4 more. Part of the daily route, aside from cleaning and checking for belts, damage, or anything else, is what we call a mail search. This mail gets stuck in the machine. As you can see, we have a letter right here. We take it, just throw it in the bin, we'll collect it, and we'll go around the other side. Look in this stacker, there's another letter. Actually a return card for certified mail. We throw that in there. The mail travels in between these belts, and we have these gates. if the mail has to be diverted into this bin, this gate will open and the mail will divert into this bin. And this paddle keeps pressure on the mail so it stays stacked up. When a particular bin gets full, the operator will take it and put it in those trays you see on the other side. So this is one stacker module, and this machine has 13 stacker modules for the total of 206 bins. As we move up, we get into what we call the reader section. This is the back of the machine again. This is the reader section. This is the device that reads the mail. We call this the WFOV, for wide field of view, or basically it's a camera. That's this thing right here. The mail passes between these belts behind this roller on this side, and the camera will read the barcode in the mail. The diverter gates have to open into the mail path, and obviously when they're doing that, they can't hit the belt, so otherwise the gate won't be able to open. So they have this very special shape so that when they open, they actually clear the belt. They're shaped somewhat like a two-pronged fork. Here's one out of the machine. Holding it in my hand, you can see the big slit in the gate, and that's made to clear the belt. As you can see, the belt fits right in there. This is what one looks like when it's removed from the machine. This is how they work. So when that opens to direct the mail into this bin, it actually opens up beyond where the belt is, which will then direct the mail right into the bin without interfering with the belt. That's an adjustment. We track these belts so that when they're running in the machine at high speed, that they don't interfere with the movement of the gates when the gate opens. Throughout the mail path on the DBCS, which is like this, between these belts, there are all these light barriers. These light barriers are I'd say about every foot. These actually not only detect the jam, anything that's in here, even for a millisecond, the machine stops. It also counts the mail, so it knows where the mail is at any given second, and it knows at what point to divert it into a bin. So the machine will be counting it, and when it sees it approaching and it breaks this barrier, if it's for this bin, this gate will open and it would direct the mail in there. So these light barriers also tell the machine where a letter is at any given point in time. They're throughout the machine, all 4 tiers, and they run the entire length of the machine. As you can see, they are everywhere. The light barriers in these machines are devices that put out an infrared light. One of them is the emitter, the other one is the receiver. So one emits the light, the other one receives the light. So there's a beam of invisible light going across these two things at all times. That does all the functions required for the computer, such as tracking the mail, the length of the mail piece, etc., and also especially to detect the jam. So if something breaks that beam for more than a few milliseconds, it'll stop the machine. This is what a light barrier looks like removed from the machine. These are the connections where you would solder the wires, and there is the little lens that, depending upon what it is, if it's a receiver, well, that's what receives the beam of light, and if it's an emitter, that's what puts out the beam of light. And we have ways of testing these things. We have little infrared detectors that we put in front of the emitter to see if she's putting out any ultraviolet light in that. And these are, again, throughout the entire machine. In addition to keeping track of the letters as they travel through the machine, these light barriers also measure the length of the letter. That tells the gate how long to stay open. Here we have 2 letters, obviously of substantially different size. In fact, this little guy is about half the size of the big letter. So it stands to reason, when the little guy goes in the gate, you just want the gate to give a quick flip whereas the big letter, you want the gate to stay open a little longer. So as the letter passes all these light barriers along the length of the machine, it's measuring the length of the letter. That tells the gate how long to stay open. This way you don't have any jams. This is the front side of the machine. This is the camera. I was just standing back here, and I'm on the other side. And as the mail gets read through this camera, it goes through these wheels. We call this the elevator because it elevates the mail to the top level. And then depending upon where the mail has to be directed, there is a diverter gate here. Either the mail will go straight or it'll come down. If it has to go to the second tier, it'll go this way. Otherwise you have another gate which will divert it to the third tier. And if it needs the fourth tier, this gate will stay closed and it'll go all the way to the bottom. And that will direct it to one of the 4 tiers that you can see there. And then it goes along the machine into the appropriate bin. And all these lights at the top are all indicating lights, telling you when a bin is full, half full, whatever. Okay, we're underneath where the camera is. This is one computer. You see that white air filter on it because of the enormous amount of dust. And right underneath it is the second computer. It has this door which also has an air filter on it. So these are the 2 computers. Everything is off now. So we're going to vacuum the machine, clean it all up, and we'll run the test deck, and you'll see what this thing looks like while it's running. Okay, before we crank this baby up, I wanted to just point out one more thing. Let's open up the stacker here. We have this special key we use for opening these doors. Every one of these stackers has its own motor. And that's this guy right down here. I can't seem to be able to zoom in. But that's the motor that drives this shaft, this black shaft, which turns everything in the machine. It's a large motor. Everyone has one. The machine in total will have 13 stackers, so there's 13 motors just for the stackers. And we have a motor running the feeder and a motor running the reader. So there's a lot of motors. If the machine has to stop for any reason, it employs dynamic braking. So when I run the machine and you see me stop it, you're going to hear this grunting sound, which is a reverse electrical pulse that's injected into the motors and causes them to stop on the dime. This way they don't race out of control, and if there's an emergency or whatever, the machine will, if any of these doors open while the machine is running, it'll instantly stop. There's safety buttons. These are interlocks. If you want to run it with the door open, you pop this out, grab it, just pull it out, and you'll be able to run the machine. Of course, only the technician is allowed to do that. We are looking at the pick-off belts of the machine. Lift this up, you can see the belts, there's 6 of them. As this bounces, it's feeding, it picks off one letter at a time, kind of like when you lick your fingers and thumb through some papers. This is a servo motor. It looks like it's spinning continuously when it's running, but it's actually moving in kind of like in spurts as it picks off one letter at a time. But it does so rapidly, it looks like it's spinning continuously, which we'll see when we run the machine. We close this little door here, you see these LEDs which record the letter going through. See, as I put my finger through, you'll see the LEDs tracking my finger. That tells the machine where the letter is, the length of the letter, the speed of the letter, as it's fed into these belts. This is with the feeder closed. You can see how tight that gets, and it goes right into this, and it's fed through the rest of the mechanism of the machine. Okay, so we're going to open up this feeder. Machine's powered up now. We're just bringing up the computers. We'll be able to run a test deck and get a look at this thing in operation. We're at a different machine now. This is DBCS number 4. These feeder belts, you see the different colors on them. That's supposed to be like a wear indicator. The green obviously is good. You get to the yellow, it means it's wearing, and the red is like no. This black part of it is just the part that grips the pulleys. But we never let them go that far. We usually change these on a daily basis, every single day. these get changed. There are also controls in the machine for setting the gap setting. So not only does this tell the machine the gap of the letters, you're also telling the machine, the computer, how far apart to space the letters. Obviously, the smaller the spaces between letters, the faster the machine is going to run. Alright, the computer is almost up. Still waiting for the screen to come on and the system to come up completely. This is the test deck. It's a 300 card test deck we run. It's basically artificial mail. You can see each one has a barcode on it, and all different barcodes, all different types. A few skewed barcodes to test the machine for being able to read barcodes that are not totally straight. This is the feeder again, and we're going to run this. We're going to leave the feeder open so you can see this in operation. Okay, the system is still coming up. We're going to take a look inside the reader. This machine is also designed to read the ID tag, which is the fluorescent barcode in the back of the letter. If we look down in here, you're going to see that purple light, which is an ultraviolet reader. And that reads the back of the letter for the fluorescent ID tag. Okay, it's now ready to process mail. We'll hit the button. And now we will hit the start button. You're going to hear 10 seconds of warning horns and flashing lights. That's to warn any operators in the area that the machine's going to start up. Okay, she's starting up. See, all these lights are flashing. Tell you the machine's going to kick off. Now we close. Well, we got a problem, it looks like. Okay, we got a jam. Let's see where the jam is. We'll come back. Okay, the jam was just a twisted light barrier. I probably hit it when I was vacuuming. Flashing light means the jam's clear. Let's try this again. I'm going to close the feeder. Alright, looks like we had a perfect run. We get these things to try to run around 40,000 letters per hour, and she ran at 40,000. You can see the run number right there. There we go, 40,000, right on a button. So she's in great shape. The DBCS computer system can tell you when there's a problem with the machine. For instance, I just tried to start this machine up. There was a broken wire on one of those light barriers, which I just soldered. And you can see from the screen here, there's an image of the entire machine telling me which module had the problem. It shows up in red. It's a little smoky looking because I made the repair. And the light's blinking to tell us that the barrier is okay now. Alright, now we'll watch the test deck actually go through the feeder. Start this up. We'll take a view of it from this angle so you can see that set of pickoff belts in action. That was the 300 card deck. Alright, we have this set up now to do what we call a fan sort. We'll see this thing do some real sorting. It's going to be just the first 7 bins. Alright, we'll go to the reader here where you see most of the diverter action taking place. Alright, we just sorted the 300 cards. We told the computer to do it in a random order so you can see the first 7 bins, which is where I directed the mail, the test mail that is, all contain test cards. And we just hit stop on it, and we'll clean the bins out now. Alright, we mentioned before how this machine uses dynamic braking for stopping. I'm going to start it up now. I'm going to hit the emergency stop to show you how quickly this thing can just grind to a halt. I'm going to hit this red button right up here, but I'm going to show you the mechanism when I hit that stop. Okay, here goes. You can see she grinds to a halt in a split second. That's dynamic braking, and that's in case any type of an emergency or anything, the machine will absolutely stop on a dime. Okay, this is a little bit of a close-up now with the diverter mechanism and the stacker modules. The mail travels between these 2 belts, between this one and this one. Here's the diverter gate. This will open, directing the mail into the bin. Here are the light barriers. Anything jams between these 2, it stops the machine. And this is another diverter gate. The pink ones are the newer ones. They replace the black ones. This is an original gate. And this is the transport belt. This runs the length of the stacker. Again, sandwiching the mail in between here. Whenever there's a gate, temporarily there's no belt. And if it's going to go straight, the gate stays closed and the mail will just continue along. And go straight on to the next gate or the next stacker or wherever it's programmed to go. I'm now going to do a demonstration of sorting. We're going to do a sort. We're going to sort a 300 card deck. I'm going to go to the back of the machine and you're going to see all the gates in operation. I'm going to confine it to tier 2, which is the second deck right here. I got the back of the machine open. The doors are open. That's why we can see through it. I'll back up a little bit so you can get an idea where this will be sorting. It's going to be the second tier. So that'll be bins 2, 5, 9, and 13. I'm going to program the machine to sort just to those 4 bins, and you'll see all the gates in operation. I'll set it up to do it randomly, and we'll go around the back and we'll get a look from the back. Okay, this is the back of the machine. These are the same 4 bins. This one, this one, this one, and this one. So we're going to sort, and the mail is going to come in, the test mail is going to come in, and you're going to see all these gates moving to let the test cards in the respective bins, and then it's going to do it randomly, no specific order. Again, these pink ones are the new gates that were replaced. Here's one original one, but this one's not going to do anything. We're just going to go up to this bin, because this gate is for this bin, because the mail goes in at an angle like this and winds up in that bin. The gate for bin number 1 is way back over here. It's actually a little bit into the reader. This is the first module of the machine. Now back up a little bit and you can see what this looks like. And of course this red thing is the e-stop. If you push that, it lights up. Okay, now we'll load the sort plan and get some cards running. Okay, this is how we set up the sort plan. This is the computer screen. Have the low pocket set to 2, hot pocket set to 13. We're confining it to tier 2. Tier 2 is selected, and fan sort random, so it's going to randomly place the cards in bins 2 to 13 on the second tier. That'll be 4 bins. Now we'll hit start and run around the back. Okay, the machine's getting ready to start up, and all these cards are going to come in here. Okay, I just stopped it by using the E-stop. You saw how quick that stopped. And there is the 300 card test deck spread out among the 4 bins. And that is a sort plan test. Alright, once again we're in the back of the machine. This is the reader section where the mail is actually read by the camera. This device right here with the 2 little green LEDs, that's the thing that reads the fluorescent ID tag in the back of the envelope. This right here is the camera that reads the black barcode on the front of the envelope. If you look, you can see a small slit in this metal plate. That's a sapphire glass. Behind this is a whole array of LEDs. This foam roller keeps pressure on the mail, so it stays pressed against that glass so it can get a good read when she runs through. If I pull this back, you can see there's belts there also. There's those 2 green belts that keeps the mail compressed against the camera. Once it passes the camera, it goes into the elevator around those 2 round bull wheels that elevates the mail to the top, and then it starts to sort. This is the back of the machine again. This is just the timing belt to keep all the gears, not the gears, but the bearings and the rollers timed. And we're going to run another sort plan, and you're going to see the mail come through here, and that camera will be flashing. The LEDs flash just for a millisecond so it can read the barcode, and it will do that every time a letter comes by. Okay, she's going to start up any second. Alright, I'm going to hit the E-stop again to shut it off. Okay, that stops the machine. You can see at this point where the mail goes from straight up to from a vertical position, it starts to bring it to a horizontal position so it can go into the reader. That's this point there where the belts start to flatten out a little bit. Okay, this is the front. This is that point I was just showing you where the belts flatten out. This way it goes horizontal, and it goes around the first bull wheel, and it travels up into the second bull wheel. It's a little dark in here, but I'll open this door and bring more light in. You can see that a little better. And then it starts up at the top and goes through whatever the vertigate the sort plan calls for. This is a variant of the DBCS. It says DBCS 10 on it. This is actually a DBCS OSS, which stands for Output Subsystem. The back of the machine is the same as far as all the bins. The reader is almost the same, but we have an inkjet printer here. This machine will actually print barcodes. And this is the print head that prints the barcodes. You can see that heavy cable. And right here in this slit through here is where the barcode gets printed. Remove this cover, you can see the actual slit in there where the print head is. This area of the machine here is called the dry line. The mail will run through here just to give the ink time enough to dry before it goes around and back in here, which is where the camera is and the reader. Now we're going to run a test deck and you'll see the mail zipping through all these belts and pulleys and get an idea of how this machine works. Okay, this is the inkjet printer that prints the ID tags on the back of the envelopes. There's a 10,000 volt charge on the tip of this thing. That's what controls the spraying of the barcode. There's a very similar one that is used for the black barcodes. Okay, I'm going to hit the start button and we're going to watch the 300 card test deck go through the machine. The front of this is basically the same as the other DBCS. Alright, there it goes. This thing is called a WAVE. That stands for Work Assist Vehicle, and it's electric, and you can go zooming around the plant with this thing, and this section where you stand actually goes up. It's a lift. This will bring you up, oh, I don't know exactly, but approximately 10 feet. And you got these little safety things you close while you're in there, and here's the controls. And it's a handy dandy little thing to go up and check the tray line, or if you have to get up and service any of these pipes on the vacuum or whatever. Very handy piece of equipment.
Start.
Okay, we're on the WAVE. I'm going to take this thing up to show you how high it goes. Close the gates in the back, otherwise it won't go up. And away we go. Alright, there we go. This is just about maximum height. You still maneuver if you have to. Alright, now we'll come down. And we'll see several shots taken while we're all the way up on this device here, so you get a bird's eye view of some very exciting things. This is the AFSM 100 automated flat sorter machine. She's running in test mode now. Alright, so this is the computer monitor for the, what is it, AFSM 100. Let's see if we get a close-up here. That's the machine. Yeah. Everything can be monitored.
We're ready. So it's got 30.
Oh yeah, Clink is coming.
Alright, we're up on the this thing called a wave. It's actually a lift. We're looking at the AFSM 100 from the top. This is where the mail comes after they prep it down on the end over there. It travels along this track, and here is that little elevator that you just saw bringing the mail down to the feed table. There's one waiting to go into the feeder right now. And they call these induction stations, where the mail actually goes with the feeder. All right, here goes one. So that basket's going to empty. It's going to go right into that elevator. It lift it up, and there it goes. The empty goes back, and another one full of mail takes its place. Over here we're going to see it again. The empty's going to go in that little elevator. There it goes, lifts it up. And another tray full of mail is going to take its place down the elevator. Here you have automation at its finest. And there's all the baskets of mail waiting in line on the conveyor system. Huge, huge machine. Very complicated. We opened up the panels and we defeated the interlocks. We're going to see how the machine inducts the mail, the flats, and where it begins the sorting process. That's the mail sitting outside. I'm on the inside of the machine now. Alright, there it goes. This is the small bins that the flats are dropped into, and they go. It's a conveyor system. Goes through this, and then they drop into the proper bucket. And these are the buckets that automatically get loaded. When they're filled, they're automatically removed. And there's the labeling machine. They put the barcode on them.
Go ahead.
Alright, we have a bucket now. We just simulated that it would be full. See how it automatically switches. Now another one's going to fill its place. Now we'll do another one. Alright, this AFSM 100 is down for service. You can see the length on one side. There's the spiral that the mail goes up. There's the track it follows. Here's the other side of the machine. and the buckets come this way, and then they will go up the spiral and follow their way through the tray line. Okay, we are looking at an absolute monstrosity. This thing is a brand new machine called the FSS for Flats Sequencing System. All these yellow things are the carriers that will carry the flats. Those are the large, like brown envelopes that you mail, and feed them through the machine. And this thing, the size of this thing is just incredible. We're going to try to get it all in here. It's impossible to get in one shot. We're going to have to walk around it. It's an absolutely huge. It's not even running yet. It's still being built. It's got some problems that they're trying to figure out. I'm underneath it right now. I'm walking through it, and it's extremely complicated. You can see all these rollers where those carriers are going to travel. Down this way is one of those elevators like you saw on the AFS 100, but just a lot larger. This is apparently one of those elevators. Here's a cage with some conveyor equipment in it. Whatever it's going to do, I have no idea. As I said, this is not functional yet. This appears to be one of the feeders, as it's labeled over here. It says feeder number 3. And it looks similar to the AFS M100. This is another one of these elevators. There's apparently an induction station where the mail was pulled in and sorted somehow. And I'm walking through. There's some of the insides of this thing. This thing has to be as big as a football field. It is just incredible. You can see the length of that. We're going to go around the other side and have a look. More conveyor system. Alright, I'm going to put this on pause and go on the other side. Alright, before I get to the other side, I just passed 2 more induction stations. There's one here with the elevator. There's another one right next to it. There's the contraption like you saw on the AFS M100 that will pull the mail out of the plastic carriers and put it through the feeder. Alright, I'm on the other side of it now at the front of it. I mean, this platform here looks like the stage at Radio City. I mean, this thing is just so huge. There's a power cabinet. There's some blue carriers. Apparently different than the yellow ones for some reason. There's a stairwell to get up on top of this thing, which will go up. This is the top of the machine. There's another stairwell that you can go down in between. We'll take a walk down here. Now I'm actually in the middle of this thing. These are all the letter carriers. This red cord here is apparently an emergency cord, like you see in the old railroad trains. I guess you pull this thing and it'll stop the machine in case someone gets their arm caught in it or their head caught in it or something caught in it. And it is just goes on and on and on all the way to the end over there, which I'm not even going to bother going down there. Cabinets with electronics. There's probably more wire in this thing than the space shuttle. More electronics. Alright, we're going to walk back to the end. I'm going to go back around and we'll see the other side of it. Okay, this is the other side of that type of alleyway I was just walking down the middle of the machine. Now I'm on the left side of it. Apparently this thing has 2 layers where these plastic containers that hold the letters will come out and ride along the track, I guess, when they're full, similar to the AFS M100. And now we're just walking along the length of this machine. There's a digital display. Now, as you can see, I'm not even near the end of it yet. I'm going to turn around and show you where we just came from, just to see the size of this thing. Very large machine. Millions of dollars of your stamp money at work here. There's some elevated platforms. Go underneath here. Here's the more conveyor mechanism. I don't know what these platforms are for. They're probably something to jump off of if you can't fix the damn thing. Well, I'm walking underneath here to the other side of it. Truly an absolutely humongous machine. It's hard to even take this thing in when you're standing here live looking at it. It's just an amazing piece of equipment. Alright, this is a view partially up this metal staircase, looking at the top of the machine. Alright, I'm at the top of this metal platform of this FSS machine. You can see the size of this thing. And once again, this is your stamp money at work. This yellow thing is a diverter. As the trays come along, it will divert the baskets, trays, in whatever direction they have to go. If it has to go straight, that thing will actually turn and send them straight. These all have to go off to the left branch here. And they're going to follow this route down to another system where they'll be offloaded and packed up to leave the building. Alright, here we are way above ground. I'm up about 10 feet or so with the top of this tray line. And you're going to see some buckets of mail come by. There's that spiral sending mail up in the other direction. And here comes some buckets of mail. As these things travel the line, the system will read barcodes that are on the boxes and send them accordingly along their way. Those red lights right now reading barcodes as it goes by. Again, this red light over here is reading the barcodes as the trays come by, so it knows what to do with the tray. These orange things are part of like a piston. If this mail has to go down this chute, that piston will shoot out, kick the box, and push it down. And it sits here until someone manually picks it up and puts it in a postcon. Well, we're actually in the midst of a bunch of this equipment right now. We have walkways like this so we can get around the conveyors. You can see this conveyor is moving right here, even though there's no mail running. Here's another one of these devices that thins the mail out. And you look along this, and these are all mail processing pieces of equipment that do the cancellation and detect if there's a stamp on the envelope, all of that jazz. These are called AFCSs, for Advanced Facer Canceller. This is all automated. I mean, each machine has like one operator, but just to make sure the feeder is not jamming. A lot of equipment. Okay, this is the inner mechanism of an AFCS, which is an Advanced Facer Canceller. It faces the mail, cancels the stamp. This is the thing that produces that ugly cancellation, the Inkjet printed cancellation. And this is the Inkjet printer right here. This whole unit replaced the one with the die. This is the kind of stuff we work on. These are the various bins the mail is sorted into. And this is the operator's console, where the operator stands, and this is the feeder where you put the mail in. Very similar feed system to the DBCS. There's more of the other side of the mechanism. These are manual cancellers. When I say manual, I mean all these things do is cancel mail. We lift this up, you'll see the die in there. That thing right there is the die that rotates and cancels the letters. Here's where they do a lot of the changing of the dies for the canceling machines. This is a pot of the black ink, very special ink, and these drawers contain all the dates, months, dates, entire dies. As you can see, here's a die, cancellation die, and all these little things. These are all the days of the month and so on and so forth. And these are the inks for the ID tags, the fluorescent inks. So you see the ID tag in the back with that fluorescent ink. This is the stuff. Okay, this is the Sios machine. This is the famous machine that did that return to sender thing, that article that was written in the Stamp Insider. Anyway, there's the rolls of paper. The machine cuts. There goes the tugger, by the way. This is one of these maniacs. Anyway, these are the rolls of paper the machine cuts to form the return address labels. This is just part of the mechanism, all the belting that the mail travels through. Opened up a few panels so you get a look. This is actually where the label is applied, right here. There's one there and one here. All these black things are light barriers. If any one of these gets blocked, the machine instantly stops. Emergency stop. And of course the bins. Also a very large machine. This machine we call the lim. It's a label machine. This is the machine that places these small paper labels, I'm holding in my hand here, over the barcode so they could print the new barcode. Because there's no way really to obliterate a barcode that the camera won't see it. So we actually put a paper label over it. This is the continuous roll of paper, which is adhesive on one side, and it's cut and stuck over the old barcode. And this is where that happens, right in here. There's the cutting head. It's a very small machine. There's only a few bins. Okay, this is the inbound. And all this piping and tubing you see is all there to sense any infiltration of biohazards, anthrax, anything like that. This is a mail sorter here. All this piping, that's what all this stuff is. This is all to detect any type of anthrax or any other type of agent they may put in the mail, poisons, whatever. Very, very huge and sophisticated system. Again, this is all inbound equipment. This is called the waterfall, where the mail is thinned out. It's dumped and it's thinned out, and all along the route it's got these pipes that are constantly sampling the air to make sure there are no contaminants in the mail. This big roller spins backwards to thin the mail out, and whatever fits underneath that crack is a thin layer of mail. It carries on and then goes in for more processing. Drops off, goes into that narrow slot. More bio detection equipment. This is all part of the bio detection system. You see all this piping. This is all air sampling for all this machinery. This is the channel where all the mail passes through. Everything is encased. This way air could constantly be sampled. See, there's very, very small areas where it's open. Otherwise, everything is encased. Here we have the piping underneath the table. And that's where the air is drawn up and into the main system that continually checks for any type of poisonous agents or anthrax or whatever. Anything that shouldn't be there. This is also all part of the bio detection system. There's a ladder and a catwalk up there for this huge piece of equipment. And these are all the vents that take in the air in order for it to be sampled. You have these canopies, and there's the air pipe that draws the air up as the mail is being dumped. It's at specific points along the line. These are the waterfalls where the mail will go up. It gets thinned out by a reverse operating roller, which will move this plastic. You can see it in there. Well, actually, not in that one. Let's take a look up in here. Yeah, here's one. Roller turns backwards to thin the mail, and there are the pipes to take the air for sampling by the system. This is where flats are canceled manually. You can see the cancellation dies here. They're rather large. There's the ink roller. And there's two of them. They just run the flats on this big belt. They feed them in on the end. They cancel. And they roll off the other end. They get put into bins. And here is a sample of the cancellation from the last time it was used. See, it says Brooklyn, Queens, and Staten Island. And that's what's done here on this conveyor belt. Okay, we call this the robot. This will place mail trays in these postcards automatically. It reads the barcode and it knows exactly what postcard to put the mail in. We're getting it set up to run right now. This is the computer controller for the robot. We're just trying to get it started right now, so I'll give you a little shot of this. Okay, here we got a bird's eye view of this robot at work here. Amazing machine. Notice it's placing those boxes with great precision. It knows exactly how tall the stack is, and it knows exactly where to put it.
The catcher's doing 2 half trays. There it goes, there it goes. Now it checks it. That's good to go. Make sure it's now too. See, that's going to store that after.
This is the input side of the robot. You see the tray of mail coming. It's passing underneath these barcode readers. And then it goes inside the robot cage where it is sorted by the mechanical arm. There comes a few more trays. They pause to have the barcode read so the mechanical arm knows where to place the trays in the postcards. This is called the APS machine. Stands for Automated Parcel and Package Sorter. Thing is absolutely gigantic, as you can see. And this sorts parcels and bundles and all automated. As it comes off these rollers, it just falls into these baskets. Dozens and dozens, maybe hundreds of them. This is the outbound loading dock where the trucks pull up to take the mail out and bring it to the stations. There's approximately 50 bays. You can see all the zip codes on the individual bays. And the inbound is very similar, except it's a little smaller because it's not broken down by so many zip codes. Okay, all this stuff you see here, there's these pieces of machinery. This is a new machine that's being installed now, brand new machine called an FSS. It's going to be another flat sorter. It's going to replace the AFSM 100. And that's what all this stuff is. This is still the skeleton of the machine. It's being built right now, brand new. We're one of the very few plants throughout the country that's getting one of these. It's a very new machine. This building is built on an old swampland. So we have these gauges to measure the amount of methane that's created. In fact, you can see that pipe there. It says methane vent, to vent the gases up through the ceiling. The building is built on a membrane, and all the gases created by the old swamplands are captured and sent up through the vent. And that big cage up there is a gigantic ventilation fan, of which there are many in this place, in case they need to exhaust the air for some reason. This is an automated tugger. This thing pulls mail carts, totally automated. You program it from the station. It's got an electric eye sitting on the top of it that's spinning around. I don't know if you can see it. And that thing is bouncing off targets that are located all over the plant. We have 10 of these things roaming around. They got all kinds of sensors on them and all of this baloney, so they can't run you over, supposedly. Very powerful machine, very sophisticated. We also have manual tuggers. They will run you over. We'll see if we can catch a glimpse of one of these guys racing by, certainly far beyond the speed limit. The automated ones that we're looking at, their maximum speed is like a very fast walk. You can actually walk faster than this thing can travel, and the speed's regulated. The manually driven ones, guys are absolute maniacs, and you can hear one in the background, but we'll catch one guy racing by. In addition to this methane vent, you see this tubular thing on the wall here. This is one of the targets that automated tugger bounces the laser beam off of, so it could see where it's going and knows where it is. These are located all over the plant. Let's see, there's one here. I move it down a little bit, you'll see there's another one over here. They are just everywhere. And they put them at the correct height so that, as you can see from this post car in here, this mail cart, that they're higher than the mail carts, and so is the electric eye on top of the AGV, so it can see over all the mail carts and see all these targets. This is the battery room where they charge all the batteries for the AGVs, the tuggers, all that stuff. These are all batteries. Very heavy, 1,000 pounds each, and has the gantry crane that lifts them to move them. It's an electric crane. And there's one of those tuggers back in the corner. You can see the warnings not to use any open flame in here because of the gases. Alright, we're going to change this battery in this electric forklift here.
Hey, I just plugged the other one in.
Hi, Mom. He's working for the postal inspector.
Somebody's got to do it.
I
How much does that battery weigh?
don't know, about
Don't forget to disconnect the wire, huh?
Yeah, I got my own system.
Boy, that was done like a true postal worker.
Perfect.
Very good. All right, we're at the back of the building. As you can see, this is not exactly a small place. Let's slowly go around this way. Look at the opposite direction. I believe the length of this building is something like 900 feet. And I know we clocked it once, walking around twice, plus one of the one wall is a mile. So it's also a nice place to exercise. And this is where they do the manual boxing of the mail. Any mail that has to be handled manually, all the clerks sit here, and this is where they do manual sorting. As you can see, it looks like a lot, but it's really not, considering the amount of machinery we have. This is just a small fraction of the letters that need to be sorted manually. Okay, we're in one of the equipment rooms. These large things you see here are centrifugal chillers. This is what cools the building. It's hard to get this in one shot. Now this big tank here is full of Freon.
Right. Well, what you have here is, this is the condensing side, so it's condensing the gas back to a liquid.
Uh-huh. And we have two of them. This is one.
Right. This is the evaporator side.
Here's the evaporator.
Right. This is what's actually doing the cooling.
And the chilled water circulates through the building.
Right.
And that's what keeps the building cool.
Right.
Alright, this is one. We turn around, here's the other. What's this big thing?
This is a recovery system that will actually recover the refrigerant when you have to work on the machine.
Oh, okay.
And then after you finish working on it, you will put the refrigerant back into the chiller.
And this is the second chiller.
Right, this is the one that's operating right now. Chiller number one.
What, are we running on one chiller now?
Running on one chiller that normally is one heat. You can also take a look at the screen up here. Get up on the and you can actually film what's happening.
Alright, we're going to go up on this platform to look at the monitor on this thing.
Right, it's a beautiful screen. You can see the water going in and out of the condenser and the evaporator. And you can see here that the chilled water temperature is 48 degrees Fahrenheit. And it's returning at 59. And on the other side, the condensing water The leaving temperature is 80 degrees going up to the tower. The tower is cooling that water and bringing it back down at 75 degrees. You have about a 6-degree differential here, delta T, and here you have about a 10-degree delta T. Run by I believe it's a 200 horsepower electric motor. 7 million BTUs should be able to be produced.
Yeah, how many BTUs is this?
7 million.
7 million BTUs. Air conditioner.
Right. Variable frequency drives.
All right, these are the circulating pumps
Right.
that circulate the chilled water through the building to the air conditioner.
This is pump number 2 is not operational right now. Pump number 1 is operational.
Yeah, these are very large pumps. This is the one that's running right now.
I believe it's about, I don't know if it's 650 gallons per minute or more. So, see the pressure differential on it going through. That clanking here is the check valve, keeping the water from coming back. This is the I can't think of the name. This is the Tangerine pump.
It's the chilled water return.
Right. It's the makeup water tank.
And this is the
Expansion
tank.
This is the makeup water tank. This is the expansion tank. This is the water coming in. You got domestic water coming in. This actually makes up the water for the chiller. You see at about 34 psi right now.
Yeah, that's an expansion tank. That's pretty big. Yeah, hold that. Give you an idea of how big this tank is, I'm going to stand next to it. It's a very large tank. That's an expansion tank. All right, now we're going to go take a look at the boiler room. All right, this is also part of the air conditioning system. This is taking the water. These are pumps that pump the water up to the towers on the roof to release the heat that's being absorbed by the water that circulates through the building for air conditioning. And these also very, very large pumps. How many horsepower are these motors? They look very big.
Probably about 300.
Yeah, about 300 horsepower each. Very large motors.
Back out to the plane.
All right, this is part of the piping for the water that goes up to the cooling tower. This big blue pipe you see here is for sediment runoff. Any sediment that's in the water will settle down in here and then it can be drained off at the bottom here. All right, now we're going into the boiler room. And here's another expansion tank. All right, expansion tank.
The hot water system.
Huge expansion tank, and this thing is the domestic water supply.
Domestic for the kitchen.
For the kitchen. Very large. And these are 4 boilers, gas-fired boilers. How many BTUs are these?
About 3 million apiece.
3 million BTUs each. These, of course, are used just in the winter because they're for heating. And those yellow pipes are the natural gas pipes that these things run off of. Considering the BTUs, they don't really look, oh, I guess they are big.
Well, they're very high efficiency boilers.
Yeah.
There's the circulator pumps for hot water.
There's the heating circulator pumps for the hot water.
And I don't know who picked the cold one.
Nice bright yellow. And here's the control panels.
All variable frequency drive motors.
All right, here is one of the air handlers. And this huge pipe up here has a fan in it. This is the return line. A little hard to see, but it's a very, very large system. There's another air handler. And you can see the huge pipe up above. They're a fan in there too. There's a blower in there, right?
Another return bit.
Yeah, with a return blower. Yeah, this is the return coming from the water tower, where the water is cooled. Now this entire system is relatively brand new. It's about a year old, and the air conditioning that we're looking at now and the heating system that we just came from, where you saw those 4 huge boilers, this whole system ran about $12 million. In order to get this stuff in and out, they had to actually cut a hole in the roof, which I'm going to point up to the roof right now. You can see the ceiling up there, and they had to cut a hole in the ceiling and use cranes to pull the old system out and to bring the new system in. The old system was a lithium bromide system that was used for heating and cooling. This equipment now is independent. You have a separate air conditioning system, which is what we're looking at now, and the separate heating system, which was in that other room that we just came from. But as you can see, the system is absolutely enormous. I mean, this thing I'm pointing at here, that says the York controls, I mean, you need a ladder to get up to it. And very large, very expensive system, works very well. It's a huge building, as you've seen, and this is what it takes to keep one of these buildings heated and properly cooled and dehumidified. This is the return. You got a thermometer on the chilled water return, and there's another one for the chilled water supply when it actually goes out. Absolutely humongous, huge system. Okay, we're inside one of the equipment rooms. This is mostly where all the electrical equipment is, where the incoming electric lines come, all the electrical panels, circuit breakers. We'll get around to this side over here. The building actually has its own small substation outside. All of this is all the electrical that feeds the building. A lot of power in this building. This is another one of the air handlers for the cooling system and heating system. And this is the runoff, the condensation. It's practically like having an open water spigot. A lot of condensate with a large air handle like this. This is where the mailboxes are repaired. We service every single mailbox in Brooklyn. These are all mailboxes, either repaired or waiting to be repaired. And this is our toolbox, which we now put away for another day. We can have more fun. And as you can see, we have our reading material on the toolbox at all times. In between test decks, we try to take it a little easy. Alright, we're now going up the escalator, leaving the work floor. That stop sign is for the manually driven tuggers, not that they listen to them. They blast right through these stop signs anyway. There's a bird's eye view of the place. And away we go, and we are out of here.